Was it last class I was 0 for, yeah, I think it was. 0 for 5. Not like anyone's keeping count. Jeez. All right, so that is x cubed, right? That's x cubed. And then I have the root part. The root part turns out to be what? This. So root 5 cosine theta. Okay? So that's this piece, yes? And I still need dx. And dx is root 5 cosine theta d theta. Root 5 cosine theta d theta. Do you all need colors or not? Do you want colors or not? You all right? Okay. All right, so this is kind of messy with all those root 5s, yeah? So I'm just going to make my life easy. On the outside, I'm going to put root 5 to what power? How many do I have here? 5, root 5 to the 5. I'll figure out what that is later. I don't really care. It's just a number, right? That's this root 5 to the 3rd times root 5 times root 5. That's root 5 to the 5th. And then, holy shit, what do I have here? Sine cubed theta cosine what? Squared theta d theta, which could have been a quiz problem today. This could have been a quiz problem, right? It's got sine and cosine in it. And so I look and I say, I see odd sine, right? I see odd. So what I'm going to try and do is peel a sine off. I'm going to peel a sine off. And if I peel my, yeah, let me write it down. How are we doing on time? I told you this would happen, right? That our problem would turn into, okay. So we've got root 5 to the 5th integral, all right. That becomes sine squared theta cosine squared theta. I peeled one of the sines off to the side, so sine theta d theta, right? So I peeled the odd power, I peeled it off. And this is where I was saying last class that this is where I'm sitting here and I'm thinking, right? This is my little thinking bubble, that u would need to be what? If this is going to be sine theta d theta is going to be the thing on the outside, then what is my u going to need to be? Cosine. Cosine. Because what's the derivative of cosine? Negative sign, but I'll figure out the negative part later. I need to know what it is. Yes?
Where did the second square root 5 cosine come from?
That was dx.
Oh.
That was dx.
Okay.
Yeah, you have to account for everything. This needs to be replaced, that needs to be replaced, and that needs to be replaced. So it was the dx is where this came from. All of this is dx. Okay, I peeled off, right? I'm going to make my, my what kind of sub here now? U sub, right? U is equal to cosine theta. The derivative of that is negative sine theta d theta. And I know I don't have this, right? I'm off by a sign. So I just multiply both sides by -1. Okay. I'm going to replace all my cosine thetas with u, and I'll replace sine theta d theta with du. There's one thing I need to get fixed here. What is that? There's one thing I need to address here. This sine squared. That's got to turn into 1 minus cosine squared. Because that's going to be u squared. That's going to be negative du. But that I haven't addressed. So using what we learned last time and all that homework, all those problems you did, right? This should be comfortable for you, hopefully. 1 minus cosine squared theta, that's sine squared theta. And then cosine squared theta, sine theta, d theta. I haven't replaced it yet. Are you saying the negative du? Yeah. I haven't substituted yet. All I'm doing is rewriting the sine squared as 1 minus cosine squared. I'm about to do my u sub now. It's coming, right? At this next step. So I have root 5 to the 5th on the outside of everything. All right, here we are. What does that turn into? 1 minus u squared, in parentheses, right? 1 minus u squared. And then cosine squared turns into u squared. And then the sine theta d theta turns into negative du. I'm going to pop the negative way out in front of everything. Negative out here, du. Please pay attention. That negative is from the negative du that we had. I pulled it out to the front. You don't have to do that, but root 5 to the 5th, integral, now what? Distribute through, right? Because you're going to have a polynomial now. U squared minus u to the 4th du. Can you handle that? Yes, that's, okay, so negative root 5 to the 5. And then in parentheses, because that will need to distribute through when I'm done, 1/3 u cubed minus 1/5 u to the 5th plus c. It's root 5 to the 5th, right? These two together are 5. These two together are 5. Root 5. 5 times 5 is 25. 25 root 5. I'm going to turn it into 25 root 5 instead of that, all right? But again, I'll deal with that in a minute. Are we done? Can I box it up? No, because my answer is in terms of what variable? U. I need to get back to x, right? But to get back to x, I first have to go from u back to theta, right, in terms of theta, and then once I get to theta, I get back to x, okay? All right, so here we go. I'm going to leave that on the board because I'm going to need that for my reference triangle. Maybe. Am I going to need a reference triangle? We're about to find out. Okay, I'm at this line right here. I'm about to rewrite this. I'm going to go negative 25 root 5 instead of that. So negative 25 root 5, parenthesis, okay, 1/3. What does it mean to say u cubed? That's cosine theta cubed, right? So that's going to be cosine, I'm going to write this way, cosine cubed theta. And then minus 1/5, and lucky for us, it's cosine again, cosine the 5th theta, plus some constant. That's me just replacing my u's with cosine theta. Now, I need to get to x. What was my trig sub? I've erased it. That wasn't my trig sub, right? That was my u sub, so don't get confused. You're not using your u sub for your triangle. You're using your trig sub. The trig sub we had was, so I'm getting ready for reference triangle here. What was it? X was root 5 sine theta, right? Root 5 sine theta. So I create a ratio out of this. I go x over root 5. I'm going to do that every single time I have something like this. I'm going to get sine theta by itself so that this looks like a ratio, so I can use the opposite over hypotenuse idea from the triangle. Theta, okay, x root 5. And then if you do the Pythagorean, you should get 5 minus x squared here. Not showing that again, right? This side and this side come from here. That side comes from solving it. Almost there. Okay, cosine theta is what I need, right? Cosine by definition is adjacent over hypotenuse, right? I'm kind of regretting that I simplified that now. Negative 25 root 5. Okay, and then here I have 1/3. Now, be real careful here. We're doing cosine theta, but we're cubing it, right? So the way you need to write that is this. What was cosine theta? Whatever cosine theta is, put here, and then we're going to cube it. So it was root 5 minus x squared over root 5. That is cosine theta cubed. Minus 1/5, and then I have cosine theta to the 5th. So I put in here square root 5 minus x squared over root 5 plus c. I would accept that as an answer on a test, just like that. You don't need to clean that up. I mean, that's the antiderivative. It's back in terms of x. Everything else is just simplification in terms of multiplying it out. Now, I am going to write a better version of this, but I'm just telling you, right here, I'd be okay if you can get to that. Questions before I continue? Anybody need to go outside and get sick? No? All right, so here's what I'm going to do now. I'm going to go ahead and cube the top and bottom of this. And I'm also going to push this in here. All right, I'm going to distribute, but let me just kind of take my time here. I'm going to do it this way. You're not going to like me. I'm going to do negative root 5 to the 5th. I'm changing it back to what it was, over 3. Okay, so what I'm doing is I'm changing that into negative root 5 to the 5th again, hitting it right here. I'm putting it over the 3, all right? You'll see why I'm doing it back to the 5th in a second. Now I'm going to cube the top and bottom of this. When I cube the top, it's the same as taking 5 minus x squared and raising it to the 3 halves. Because this is a square root, right? Square root, and you cube a square root is the same as raising it to the 3 halves. And then on the bottom, I'm going to cube the root 5. And the reason why I went back to this? So I can start subtracting powers. That's the first distribution from here to here. And now I'm going to go here to here. So a negative times a negative is positive. I'll have root 5 to the 5th over 5 times the 5 minus x squared to what power this time? 5 halves, right? Because we're going to take that root and we're going to go to the 5th, so it'll be to the 5 halves, all over the square root of 5 to the 5th power. And if we do that now, some good things happen. This is gone, this is gone. And then all 3 of these are gone. And up here, how many are left? 2, and what's root 5 squared? 5. So you get negative 5/3. 5 minus x squared to the 3 halves. Plus, these went away, but I still had this, so it's 1/5. And then 5 minus x squared to the 5 halves. Plus c. That's a pretty clean answer, if you ask me. Yikes, right? So each of these problems are going to be different, all right? Like in terms of what you run into. We've run into some problems where we just needed to know, like, what's the antiderivative cosecant squared or cosecant. Here we had to do the odd power of sine, peel it off, right? You might do these and you see even power of sine and have to do the power reducing formula like you did in the homework last time, right? So this is really a lot of things that can go different directions here. I think I have enough time for one more. 15 minutes should be enough time. I'm wondering if we should look at the other 2. I've only shown you one of the 3 trig subs. There's 2 more. Maybe we should introduce the next one? Yeah, let's introduce the next one, and we'll do an example. All right, so we already know what to do. We already know what to do if we see this, right? If we see, I'm doing my face again because it's actually pretty fun for me. Okay, so if we see this, right, then we let x be equal to a sine theta. And then we kind of know what happens after that, right? We have to work everything out. Now, if we see the opposite of that, like flipped over, we do a different trig sub. It'll be x is, you want it to be cosine, right? That's what you want it to be? It's not. Now, you know that sheet that you're allowed to use? Right? Where the hell is it? Where's that sheet? I thought I downloaded it. Where is it? I lost it. There it is. You see this sheet here that you're allowed to have on the exam? If you scroll to the bottom, it tells you right there, it says table of trigonometric substitutions. It tells you what the trig subs need to be for each of the three things that it could be. This we already did. X is a sine theta. We're doing this and we'll skip this one. If you flip it around, it's a what? Secant theta. All right? You don't have to memorize those. You're welcome again. I had to memorize all this stuff. I mean, it's just the way it was. It depends, really, in Cal 2, it depends on your professor. If you run into a professor who wants you to memorize everything, that's what's going to happen. And it's kind of brutal. But people have different teaching philosophies. My philosophy is that, like in the real world, right, you're never like by yourself. You're never in a room by yourself with nothing, right? So if you have resources, you need to know how to use them. So everyone needs to know that that sheet you can have on the test, and that you need to know, it tells you what trig subs to use. All right, that's the trig sub we'll use, right? If we see, now you might ask yourself, why would we use that trig sub? You'll see, when we work out a problem, you'll see why this makes things nice, all right? So let's do an example. And which one did we say looked like that? Number two, y'all want to do number two? I want to go deep. Let's go deeper into this. Let's go with number 24. Let's go to number 24. We're going to go right into the frying pan here. X squared over x squared minus 1 squared dx. This should be fun. The first thing you're going to do when I give you that problem is say, hey, that doesn't look like this. What the hell are you doing, right? You're going to be like, that's not this. So, what's going on? And then you start trying to do some weird stuff. You can start maybe doing a basic U sub, and you can try maybe integration by parts. Nothing's going to work for you. Nothing is going to work, all right? How do I know that? Because what? Thank you. Yeah, no. I know that probably from experience, right? That I know that, like, no matter what else I try, it's not going to, the only thing that I can, well, there's actually, you could try some, we haven't done it yet, called partial fraction decomposition. I mean, that's another, pardon me?
You could rewrite it to the power of 4.
How do you mean, to the power of 4?
So
You mean like expand out the bottom?
No, like
Oh.
x squared minus 1, like the square root.
Oh,
of
yes.
x squared minus 1
Okay.
to the fourth power.
Yeah, so if I got to the point where I'm like, shit, I don't know what to do, I really wish, though, that that was a square root, I could use this, right? If you get to that point, which you would need to, you would say, you would need to realize that this is a square root. It's the square root of x squared minus 1, but to the 4th power. You would have what? You would have not seen that, right? But now that I've shown it to you, now you need to be looking for it, right? You need to be paying attention for it. Saying, okay, look, I'm trying everything else. One of the big tips for me that this is trig sub is that it's in the section for trig sub, right? Like that's a big tip for me that it's trig sub. It might go some other ways that we haven't talked about yet. So I'm not going to say this will only go trig sub with trig sub, but I'm pretty sure they wouldn't put it here unless they wanted us to go that way. So, all right, that seem fair? Yes?
So basically, just to clarify,
Yes.
you're doing this because it's technically to the second, so they'll cancel to the second at
Yeah, that's really x squared minus 1 to the half to the fourth. And remember, when you have something to a power, you multiply those. Half of 4 is 2. So I'm just realizing that that 2 can be rewritten as this square root to the fourth. Okay, now that I have that, right? Now that I have that, that does look like this, right? That does look like this. And so for me, I'm going to say, all right, I'm going to try trig sub, all right? I'm going to go for it. Try it. Let's do it. A for me is what? 1. Fortunately, it's not 5 this time, right? Like, not, sorry, square root of 5. It's 1. Okay, what's my trig sub? X is 1 times secant theta. In other words, x is secant theta, right? I only put the 1 there just to stress that in the formula, it's a secant theta. Whatever a is, it's got to be there. What did I do in the previous problem once I got to this step? When I had, in the previous ones, I had a sine theta. What did I do next? Derivative. Okay, what's derivative of this? What's derivative of secant theta? Secant theta, tangent theta, d theta. That's the derivative of secant theta. Now I need to figure out, what does the square root of x squared minus 1 turn into, right? What does this thing turn into? So what's x squared for us? This is square root of secant squared theta minus 1. Oh, wait, hold on. What's secant squared theta minus 1? That's tangent squared theta. It's almost like someone made this perfectly so it'll work for us, right? That's exactly what trig sub is. It's if you have a certain form, if we have a certain form, we can do a certain trigonometric substitution that will make the ugly thing turn into something nice. Everyone understand that piece? Okay, now what? Rewrite everything. Rewrite the whole integral in terms of theta now instead of x. Here it comes. Here it comes. Here it comes. All right, equals integral. All right, the top, x squared. So I square this, right? X squared, secant squared theta. Secant squared theta. Okay, over. Be real careful here. What does the square root piece turn into? Tangent theta, right? But tangent theta to the fourth, right? So tangent to the fourth, yes? The square root part is tangent theta. But in this, there's a square root, but it's still to the fourth power, right? So the bottom is tangent theta to the fourth power. I'm going to write like that. Am I done? No, I have to put here, don't just throw d theta there. Just be like, oh, d theta. No, you have to replace dx with secant theta, tangent theta, d theta. Secant theta, tangent theta, d theta. And now you just like hope that this is all going to work out somehow for you, right? Let's see. Yes. Yes. That works, right? I can kill one tangent. Unfortunately, the secants don't cancel, right? They actually come together. So let me just rewrite this. I have secant cubed on top, and on the bottom I have tangent cubed. Oh, geez. That's scary. Okay, when I look at an integral, so this, what I like about these problems that I'm bringing to class is that I literally just printed this out this morning. So I love to do problems that I haven't done before because like you actually get to see the process of, if I get to a point where I'm like, I'm not sure, you're going to see exactly what I would do. At this point, I'm going to get everything in terms of sine and cosine and see what happens. I might come back to this, but I'm going to just rewrite this as secant is really 1 over what? Cosine. So that's 1 over cosine cubed theta over, tangent is what? Sine over cosine. So sine cubed theta over cosine cubed theta, d theta, right? I'm not sure I was not 100% sure that was going to help me, but I actually think it is. This is going to flip, right? This flips up, and this becomes 1 over cosine cubed theta times cosine cubed theta over sine cubed theta, d theta. I see where this is headed. And what's that? Where's my time? 5 minutes? It's going to be tough. It's going to be close. Do y'all agree with that? Okay, so now I'm at integral 1 over sine cubed theta d theta. Damn it. I was really hoping that would be sine squared, because if it was sine squared, that would really be what? Cosecant squared? And I know the antiderivative of cosecant squared. But it's not. It's cosecant what? This is cosecant cubed. Theta d theta. Damn it. Well, I'm sighing because there's no way I'm finishing this. So do you remember what the problem we started class with? What was it? No. Secant cubed, right? Secant cubed. This problem will work the same way as that one. We have to do integration by parts on this. I have to split this up into cosecant theta, cosecant squared theta d theta, and then I need to go and make this cosecant squared theta, make this cosecant theta, and then start working this through. Okay, that is not doable in the time we have left. So I might have to pick up here. But before I do, because I do have 3 minutes, I'm going to come back to this and see if there's any way that I could have done this, not in terms of sine and cosine. Like, I could do secant squared. Let me see. If I did secant theta, secant squared theta, is that what you're saying?
Yes, and then secant squared theta becomes sine squared.
Yeah, I could rewrite that. But does that get me anywhere? That's the thing.
Well,
The derivative of tangent is secant. So you almost have a u sub here, don't you? Let that be u. That's u cubed, right? On the bottom? That's a problem, though. So you can't replace that with something. If that were secant squared, I'd be like, yes. But it's not. So like that, what we're saying is if we let u be tangent here, the derivative of that is secant squared. Theta d theta, right? So I can replace secant squared theta d theta with du. This would become u cubed, but I don't have a way to deal with that. And that's why I didn't go that way. But I'm just making sure I didn't miss anything else. From the looks of it, I mean, I think this is, so maybe I went too far into the homework set. This problem is only bad because, you know, it's number 24 in the problem set, so I guess at this point, they're really trying to push to see how far you can go with this, like, you know. So what do you say that for you, what I'd like for you to do, let's work off of this sheet for homework tonight, all right? And I'll tell you what problems to do, because you can only do the first two trig subs. So number 1's good, number 2's good. I know we've done some of these. Number 3, 4. You can try 6 if you want. 7, 8, 9, 10. You have to just avoid the ones with the pluses. So 13, 14, 15 and 16 we already did. What, 19, 20, 21. Let's say those, right? Like that would be a good starting point. Don't go anywhere past 25. The whole idea here, and if you want, do your homework out of the textbook. right? You can do your homework out of textbook. Just again, avoid anything that has a plus between, right? If you see any pluses, just avoid them, all right? See how it goes, but do homework this weekend, all right? Do homework for this. We're going to do some more trig sub, and then after we're done with trig sub, which I think we will probably try and wrap it up next class, we get into the next topic, which is partial fraction decomposition. And then we'll be done. Those will be all the methods, and we'll be ready to start going into applications. All right, everyone, have a great day. What are you doing this weekend? Your homework. All right. And if you need to catch up, catch up. 1 o'clock. Let me turn off my thing. Right behind you. No, you're good.